On April 20th, 2026, a team of physicists published a paper Inches physical review letters proving that a single clock can tick both faster and slower at the exact same moment. This isn't theory. This isn't philosophy. It is a laboratory-verified consequence of quantum mechanics that shatters one of the last assumptions of classical physics, that time itself flows inches one direction at one rate for one observer. And the implication the researchers buried inches their conclusion. It suggests that time, the most fundamental thing we think we understand, may not exist the way you believe it does right now. But before we get to what Professor Igor Pikovski actually told reporters about hidden quantum signatures of time, listen to what one of his graduate students admitted about a measurement they performed at temperatures colder than deep space. The story begins at Stevens Institute of Technology, Inches, Hoboken, New Jersey. Assistant Professor Igor Pikovski had been wrestling with a problem that has haunted physics for over a century: the fundamental incompatibility between Einstein's theory of relativity and quantum mechanics. Inches relativity. Time is geometry. It bends, it stretches. It slows down near massive objects and speeds up far from them, but it is always definite. A clock at any given location ticks at one specific rate, and you can measure it. Inches quantum mechanics. Nothing is definite until measured. Particles exist Inches superposition, simultaneously here and there, spin up and spin down, alive and dead. These two descriptions of reality have never fit together, and for decades, physicists assumed time itself was the classical anchor, the one thing that stayed normal, even when everything else went quantum. Pikovski's team just proved that assumption wrong. Working with Christian Sanner at Colorado State University and Dietrich Leibfried at the National Institute of Standards and Technology, NIST, Pikovski's group focused on the most precise timekeeping devices ever built by human hands: optical ion clocks. These aren't the clocks on your wall. They're not even the atomic clocks that synchronize GPS satellites. Optical ion clocks are the apex predators of precision measurement. They trap a single charged atom, usually aluminum or ytterbium, and cool it down to a temperature within a hair's breadth of absolute zero. Then they probe it with carefully tuned laser pulses, counting the oscillations of light at frequencies of hundreds of trillions per second. These clocks are so accurate that if you had started one running at the birth of the universe 13.8 billion years ago, it would still be accurate today to within a fraction of a second. Data, type stat value, Matsur 13. 8 unit billion years context, accuracy of optical ion clocks, dramatic true. And that extreme precision is exactly what makes them the perfect laboratory for testing whether time itself can become quantum. Here is what the team proposed, and here is where the story turns strange. According to general relativity, a clock that moves faster ticks slower than a clock at rest. This is time dilation, and it's been confirmed thousands of times. GPS satellites have to correct for it every single day, or your phone's location would drift by miles. But what happens if the clock's motion itself becomes quantum? What happens if the clock isn't moving at one speed, but inches a superposition of multiple speeds at once? The team's calculations showed something that even they admitted was difficult to fully accept. If you place a single ion into what physicists call a squeezed state, manipulating the quantum vacuum so that the ion's position and motion exhibit quantum behavior, then according to relativity, the clock should be ticking at multiple rates simultaneously. Not metaphorically, not approximately, literally. Gabriel Sorci, a PhD candidate and co-author on the paper, explained it this way to reporters. The most famous thought experiment Inches quantum mechanics is Schrödinger's cat. A cat sealed Inches a box that is, until observed, simultaneously alive and dead. It exists Inches superposition. But what Pikovski's team described is something stranger. It's not a cat both alive and dead. It's a cat both young and old at the same time. Because if time itself is Inches superposition, then the entire history of an object, how much it has aged, how much proper time has passed for it, can exist inches multiple states at once. The clock isn't just uncertain about what time it is. The clock has lived multiple different durations simultaneously. Now you might be thinking, this has to be just mathematical abstraction. Surely you can't actually measure something like this. That's exactly what makes this paper different from previous theoretical work. The team didn't just describe an exotic possibility. They identified specific measurable signatures that current laboratory technology can detect. When the ion is placed inches a squeezed quantum state, its ticking rate becomes entangled with its own motion. The clock and its history become intertwined inches away that classical physics simply cannot describe. And when the experimenters measure the clock, they should see statistical patterns, interference signatures, that prove the clock existed inches multiple time flows simultaneously before the measurement collapsed it into one. And here is the moment inches the research that stopped me cold when I first read it. Even at absolute zero, the coldest temperature physically possible, where all classical motion ceases, the quantum fluctuations of the vacuum itself still affect how the clock ticks. Time does not stop. Time wobbles. Time fluctuates from nothing. Data. Type. Comparison label. Erco. Classical physics. Time flows uniformly. Label. BWE quantum reality. Time fluctuates even at absolute zero. This is staggering. It means that even inches a perfectly cold, perfectly still universe, the passage of time would still be uncertain, still inches flux, still quantum. Pikovski's own words, inches, the press release, are worth listening to carefully. He said, and I quote, "Time plays very different roles, inches quantum theory and inches relativity. What we show is that bringing these two concepts together can reveal hidden quantum signatures of time flow that can no longer be described by classical physics. Hidden signatures of time flow." That phrase has been quietly circulating among theoretical physicists since the paper appeared, because what it really implies, is that the time we experience, the smooth, flowing river of past, present, and future, may be nothing more than an averaged-out illusion. A macroscopic statistical effect that emerges from something much weirder happening at the quantum level. The same technologies being developed for next-generation atomic clocks and quantum computers may, within the next few years, give us our first direct experimental view of time itself behaving quantum mechanically. The experimental teams at Colorado State University and NIST are already preparing the laboratory work. Sorci confirmed that current atomic clocks can already detect tiny differences, inches time caused by thermal vibrations at minuscule temperatures. The instruments exist. The math is published. What remains is to flip the switch. And here is where this story crosses from physics into something that should make every thoughtful person uncomfortable. If time itself is quantum, if proper time can be inches superposition, then what does that mean for causality? For memory? For the difference between past and future? Inches our everyday world. An event either happened or it didn't. A clock either ticked twice or 3 times. But if Pikovski's framework is correct, then at the deepest level of reality, that distinction breaks down. An event can have happened and not happened. A duration can have lasted and not lasted. We have spent 4 centuries since Newton building a worldview based on the idea that time is the one thing we can trust, the one constant, the backdrop against which everything else changes. That worldview is now cracking. The paper Inches Physical Review Letters is not the end of this story. It is the beginning. Within the next 2 to 3 years, experimental confirmation, or refutation, will arrive from the labs at NIST and Colorado State. And depending on what those measurements reveal, our understanding of reality itself may need to be rewritten. So I'll leave you with the question that the researchers themselves have not yet answered. If a clock can be both young and old at the same time, and if time itself can exist inches superposition, then what does that mean for you? For your memories? For the moment you're living inches right now? Are you certain this moment is the only moment that's happening? Tell me, Inches, the comments, what you think the experimental results will show when they come in. And if you want to follow this story as the laboratory tests unfold over the coming year, subscribe and turn on notifications. Because when time itself goes quantum inches a lab for the first time, inches history, you'll want to be there to see it.